or leak. What is outlet or leak? An outlet is a pipe. An outlet is a pipe which is connected, which is connected with the tank, with the with the tank or cistern or cistern, which empties it. Okay, this is what outlet, or you can also call a leak. Understood? Concepts and formulas. So what are the formulas we are going to use? First formula: if an inlet pipe, if an inlet pipe can fill a tank in X hours, a tank in X hours, or a cistern which X hours, then then part of the tank, part of the tank filled by, filled by, filled by pipe in 1 hour is 1 by X. 1 by X. Second point. If a pipe, if a pipe can fill, can fill a tank, can fill a tank in X hours, in X hours, another pipe can empty, can empty the full tank, can empty the full tank in Y hours, in Y hours, then open both pipes. Then we have three different cases or two different cases. Case 1, if Y greater than X. Y greater than X means Y value is more than X. That means filling pipe will, will take less time than the empty pipe can take. Okay. The part of the tank filled in 1 hour is, in this case, the part of the tank filled in 1 hour is equal to 1 by X minus 1 by Y. Case number 2. If Y is less than X, then part of tank, part of tank filled by, filled, filled in 1 hour equal to 1 by Y minus 1 by X. 1 by Y minus 1 by X. Point number 3. If a pipe, if a pipe can fill the tank in X hours, can fill the tank, fill the tank in X hours, and another pipe can fill the tank in Y hours, another pipe, another pipe can fill the tank, can fill the tank in Y hours, both operated, both operated, then part of the tank, part of tank filled is equal to 1 by x plus 1 by y. 1 by in 1 hour actually, filled by 1 hour or in 1 hour. No problem what you what you can take, no problem. Fourth, if a pipe can fill a tank in X hours, another pipe can fill the tank in same tank in Y hours, but the third can empty the full tank in Z hours. Okay, the same scenario, but one more pipe is there and it will empty the tank in Z hours, full tank in Z hours, and all are operated. Then the formula part of the tank filled by in 1 hour, the formula is 1 by x plus 1 by y minus 1 by z. So this is the three variety of formulas we are going to use for the concept of pipes and cisterns. And the next one is races and games. Races and games actually this is actually it depend upon the scenario how he was discovered the uh, questions. Okay. This is the topic for the chapter 1, and next we will move to chapter 2, which is matrices. Okay. So first we will define matrix, a rectangular arrangement of mn elements in the form of ordered set of m rows, each row consisting of an ordered set of n columns is called a matrix of order m by n. A rectangular arrangement of m rows with n column elements is called matrix of order m by n, where m is equal to number of rows and n is equal to equality of matrices. Two matrices are said to be equal if elements are same and order is also same. And the types of matrices, this is not important, but we will define a little. Row matrix means only one row it is having and different columns. Column matrix means only one column and different rows. Zero matrix means if all the elements are zeros, then it is called zero matrix. Square matrix means number of rows is equal to number of columns, it is called square matrix. Diagonal matrix means only diagonal elements exist and other elements in the matrix are zeros, and diagonal matrix is a must and should be a square matrix. Scalar matrix, diagonal elements are existed and not one, then it is called scalar matrix. Identity matrix will be, it is also a diagonal matrix, but it should be one. Diagonal elements will be one, other elements will be zeros. It is called a unit matrix. Addition of two matrices, for addition of two matrices and number of rows and number of columns, both will be same in the both matrices. And additional subtraction and a plus b additional properties. A plus b is equal to b plus a. That means addition will be commutative law. It satisfies the commutative law and also satisfies the associative law, that what it says, a plus b of plus c equal to a plus of b plus c. This is what called associative law. And also a plus o is equal to o plus a is equal to a. So o is called identity matrix according to addition. And cancellation law, the cancellation law of matrices is a plus b is equal to c plus b. Then you can cancel both and you can equate it like this. Okay. And multiplication of matrices, multiplication of properties of matrices with scalar. If lambda plus mu of A is equal to, you can write lambda A plus mu A. Lambda A plus mu A. Or lambda of two matrices take A plus B, then you can write lambda A plus lambda B. All elements are multiplied with lambda. And lambda of mu into A, it should be, you can write lambda into mu into A separately. And minus lambda into A, it will be equal to minus lambda A. Okay, these are multiplication with a scalar. Multiplication of matrices. Properties of multiplication of matrices. And clearly AB is not equal to BA. Matrix multiplication is not commutative property. And also, but it satisfies the associative property. That means AB of C is equal to A of BC. Look at the order is not changed of the ABC. It will be accepted. And identity property. IA is equal to AI is equal to A. So I is called the identity matrix in this multiplication law. And A of B plus C is equal to AB. Don't change the order of matrices AB. Okay. AB and AC. Don't write BA and CA. Okay. In this case, and one more thing here. For example, AB is equal to AC. You cannot cancel A like this. And you cannot say that B equal to C. Okay. It will be not accepted. Cancellation is law is not accepted in this matrix multiplication. And multiplication with a scalar. Multiplication with a scalar means lambda of AB is equal to either lambda A into B, or this is also equal to A into lambda B. Okay, it accepts the rule. And if AB is equal to 0, then either A is equal to 0 or B is equal to 0, and it is not necessary that AB is equal to 0. Okay, it does not mean that A equal to 0 and B equal to 0. It cannot be, or maybe and cannot be, both are possible. So we can't say that they must be zeros or they cannot be zeros. Maybe sometimes A into B will be 0. We cannot decide with a property. And multiplication integral powers. Integral powers on matrices. For example, say something A square is equal to A into A. A into A. Okay. And A power M whole power N is equal to A power Mn, you can write. And always if I is identity matrix, I power M is equal to IA. Matrix polynomial. Sometimes you have to define, for example, say f of x is equal to x square minus 3x plus 5. Okay. Then if you insert in the place of x a matrix A, then you have to write A square minus 3 into A plus 5 into I, you have to verify. Don't take constant as it was. Okay. And next, transpose of the matrix. Transpose of matrix. Transpose of a matrix. If A is a m by n matrix, m by n order of matrix, A transpose is denoted by A power t or A dash. And its order will be n by m. That means rows will be changed to columns, columns will be changed to rows. The properties of transpose is A dash whole dash is equal to A. And if there is A plus or minus B whole dash will be equal to A dash plus or minus B dash. Okay, some constant take Ka whole dash is equal to K into A dash. Only constant will not affect, coefficients will not affect, only matrix will affect. And AB whole dash is equal to B dash into A dash. And if you take three matrices like A into B into C whole dash is equal to C dash, B dash and A dash. And next concept is symmetric and skew symmetric matrices. Symmetric and skew symmetric matrix. Symmetric and skew symmetric matrix. A matrix is said to be symmetric matrix if A dash is equal to A. A matrix is said to be skew symmetric matrix if A dash is equal to minus A. Okay, that means if rows and columns is changed, then it will be expressed just by these properties. Okay, any matrix can be expressed as a it's sum of the symmetric and skew symmetric matrix. Then A can be written as A plus A dash by 2. A plus A dash by 2. This is a symmetric matrix, and 1 by 2 of A minus A dash, where where A plus A dash by 2 is equal to symmetric matrix, and A minus A dash by 2 is skew symmetric matrix. Okay. Invertible matrix. Invertible matrix or inverse of the matrix. Invertible matrix. If AB are two non-zero matrices and AB is equal to BA is equal to I, then remember this definition. Then B is equal to A inverse. Then matrix B is equal to what you can call it? Inverse of A. And it is denoted by A inverse whole power minus 1.